Hi everyone. I hope you guys can see the screen that I'm sharing, and also hear me. If there are any challenges, please let me know in the chat so that I can fix that. Okay. Uh, Hi everyone. Good evening. Thank you for joining the introduction session for SQL with Skillslash. Before we start, let me just give a quick introduction of who I am and what I do. So I am Parikshit Sohani, and essentially I'm a mechanical engineer turned data scientist. I also did a similar course like Skillslash is offering right now in 2017. So that's when I did my 6 months course in big data analytics. And since 2017, I've been working in the domain of data science. For the last 5 years, I worked for multiple corporates and MNCs. And currently, I'm running my own startup. In my startup, what we are doing is we are building assistive technology devices, which are embedded systems, sensor-based devices for deaf people. So deaf people usually interact in sign language, and most of us don't understand or find it difficult to interpret that sign language. So we have developed smartwatches with sensors on each fingers. So we map the movement of the sign language user, and using AI and ML, we convert that into speech and text, so that whenever a deaf person communicates in sign language, the smartwatch will speak out what they want to say. So that is the startup I've been working on. And we are almost a 2-year-old startup now. We are in the stage of pilot testing and beta testing and all that. So at the end of the session, I'll of course share a link for the website of our company, and you can check out more. So today's agenda is going to be, I'll give you a brief introduction of what SQL is. And while I'm doing that, please feel free to text me in the chat if you are not following something, if you want me to repeat something, or if there are any other technical challenges like my voice is not audible or my screen is not visible. Please let me know in the chat so that I can take care of that. Okay. So again, one last time, welcome everyone, and we'll start with the session on SQL. Okay. So obviously the first question is going to be, what is SQL? So SQL is nothing but a structured query language designed specifically for communicating with databases. Okay. So right now, just try and understand at a very high level what I'm talking about. All these technical terms like structured query language, what is a database, and all these things. Eventually, I'll give you a walkthrough for that also. Okay. So as I was saying, it's a structured query language. And it is designed to deal with databases. And when I say designed to deal with databases, what are we going to do with a database? Using SQL, we are going to do the 3 M's related to the database, which is we are going to manipulate a database, we are going to manage a database, and we are going to maintain a database. Okay, so these are the 3 things. Will you please provide a recorded version? Yes, I think the Skillslash team will give you a recorded link for this. Is this workshop only for today? Yes, today is just a webinar as an introduction to SQL, and later on you can join Skillslash for further courses. Okay. Yeah. So as I was saying, SQL is going to be used for maintaining, managing, and manipulating databases. And finally, SQL has certain syntax rules. Okay. So I'll just make few things clear here, what I'm talking about. So database essentially is nothing but you can imagine a database as set of multiple Excel sheets. Volume is a bit low. I'm not sure if I can increase the volume at my end. The microphone is set at the default. Okay. So as I was saying, few terms I want to help you understand here. First is the database. Database is nothing but you can imagine database like an Excel sheet, which has multiple rows and columns, and we can store our data in that particular Excel sheet. So if you can imagine there are multiple Excel sheets, so a collection of all these Excel sheets together, you can imagine as a database. Okay. Next is the syntax rules. So when I say SQL has certain syntax rules, syntax is nothing but the way we write it. You are not able to hear me. Okay. Am I not audible to everyone? Guys, can I just get a quick feedback? Am I audible? Yes, right? Okay, perfect. So all the people who are probably facing issues, can you try rejoining the link, right? That should help you. Okay, yeah. So SQL has syntax rules. And when I say syntax is nothing but the way you write a particular code, right? So now we communicate in different languages, English, Hindi, Marathi. In order to write any particular language, there is certain rules by which we can write that language, right? The grammatical rules that dictate how a particular language can be written. So similarly, SQL also has these rules in which we can write certain codes, okay? And that certain code is nothing but the way we are writing the code is referred to as syntax, okay? So I hope this first slide is clear to everyone. Feel free to put in any questions you have, okay? Okay, so further extension to the first slide. So SQL is going to help us deal with facts, records of information. Okay, so facts and records is nothing but a collection of different numbers, words, measurements, or observation, or it can be just a simple description of things. Okay, so for example, if I'm an e-commerce platform like Amazon, and I want to deal with a database which has the products and what is the description of that product, right? This is the information that I'm storing. So in this scenario, what is the information that I'm storing? I'm storing the name of the product and probably I'm storing the description. So if I have to give you an example of all the smartphones that are available, I'll write all the smartphones in one column, and in front of that smartphone, maybe I can write some technical specifications related to that smartphone, right? So basically you can store literally anything in a database as long as it is a structured format. Okay. So now if you think about data, even video and sound is also data, but this particular data cannot be stored in a particular database. Okay. Database is always going to have a certain structure to it. So now, in order to help you understand this entire concept a little bit better, I'll talk about an real world application. Okay. Real world example. So the example is car insurance. Okay. So let's say you are working for a car insurance company and you will be collecting information from all your customers, right? So when I'm collecting all the information, I'll just ask one simple question to everyone, open to all. So let's say I am a car insurance company and I am giving insurance to all my customers, right? So what kind of information will I take from my customers? Can you guys give me certain examples of that? So again, I'll repeat the question. I am a car insurance company. I am giving insurance, vehicle insurance to my customers. In order to give that insurance, I have to take certain information from them, right? So can you think of certain information that I can ask? What kind of information will I ask my customers to give me before I can give them the insurance? PAN card, okay. Aadhaar card, yes, fine. What else? What can I take? Vehicle number, name, phone number, yes, perfect. Customer details, address, RC book, email ID, perfect, yes. Exactly, right? So these are all the details that I will take from my customer. I'll analyze all these details, and based on these details, I'll decide whether to give a particular customer certain insurance or not. So now second question I want to ask. So now let's say I'm a very young insurance company. Okay, I just started operations, and in the period of 1 month, let's say 1,000 customers have taken insurance policy from me. So basically what I have is I have 1,000 customers data that they have given to me at the time of application. I have stored that data, right? So when I'm storing this data, what can I do? I can just take all the application details from one particular customer. Let's say one customer is giving me his Aadhaar card, PAN card, driving license, and maybe his RC book and details related to his vehicle. So if I take all this information, I can take this information, store all these information in a particular folder. And in my laptop, I can have, let's say, 1,000 folders, one folder for each and every customer, right? And in that folder, I can store all their data that they are giving me, all the photos and PDFs of all the documents that they are providing. I can store them in this folder. But the problem with this is I cannot access all this information of 1,000 customers at one go, right? I have to go and search that particular folder. I have to pick out their information. If it is an image, I have to open that image. From that image, I have to read what is the information that is relevant to me. So all this entire process is very, very cumbersome, right? So in order to facilitate retrieval of information faster, in order to run my business much more efficiently, what I need is I need a database, right? So in this database, I'm going to store information like this. Okay, so whenever a person who is taking insurance from me comes to me with an application form, chances are that they will be filling this kind of an information, right? Age, gender, location, driving records, number of accidents, and so on. So all this information, I can store this information instead of a folder. I can store this information in a simple Excel sheet, right? You can consider an Excel sheet also as a database. But the problem with this is that in this Excel sheet, how many data points am I going to store? I cannot store all the data points for all the 1,000 customers in just one Excel sheet, right? It is going to be very, very chaotic in nature. It is going to be very, very difficult for me to get access to this information whenever I want, right? So for example, I'll tell you why I need access to this information. Okay, so let's say 1,000 customers have already taken insurance policy from me. Now for these 1,000 customers, I want to understand who are my top customers who are paying me the highest premium, right? This is the information that I want. I have customers who are paying me premium for their car insurance, let's say ranging from 5,000 rupees to 25,000 rupees. Now, what I want is I want to access all those customers who are paying me premium more than 20,000, right? If I want to access this kind of an information, it becomes very, very important for me to access this information quickly and efficiently. I cannot go and look at every folder and look at what document they have provided, make a note of all their numbers, and then finally come up with a list of customers who have paid more than 20,000, right? So in order to facilitate this kind of an information retrieval, I am going to rely on something called as a database. Okay. So is the notion of database clear to everyone? Why is it required? How am I using this database to store my information? Any doubts or questions regarding what a database is? Okay, perfect. Great. So we'll just try to drill deeper on what this database is. Okay, so as I said, a database is a storage system that allows users to keep, organize, and manage their data. Okay, so it is a complex program designed to store this data. Complex as in there are many connections to it. Okay, it is not complex to design. It is not very difficult to conceptualize. Complex meaning there are multiple links and connections with each and every database. That's why it turns out to be a complex system. Okay. Lastly, what is a database? Database is nothing but it is going to keep our data correctly and it is going to help us retrieve this data fast. Okay. And it is going to help us retrieve this data effectively. Okay. So storage systems that allow users to keep and maintain and organize their data are called as, sorry, what is this? Yeah. Sorry for that. I think this is the same slide. We can skip this. Okay, so few examples of database are going to be Microsoft Access, SQL Server, and Sybase. So all these different customers or all these different companies, there may be many more than that. So all these different companies can help you host your database on their systems. Okay, they will have all the storage and compute space, but you can host all your entire database on these systems. Okay. So now let's look at what is a database and some basic things of what it consists of. Okay. So again, as I said, you can imagine a database as an Excel sheet. Okay. A simple Excel sheet. The image that you are seeing in front of your screens is again that of a very similar to that of an Excel sheet, right? So in a database, there are certain technical terms that are used. Okay, we are not going to refer to our database in terms of rows and columns. Okay, so in a database, the rows are referred to as records. Okay, and columns are referred to as fields or attributes. Okay, so these are the terms which are most commonly used in the industry. So whenever someone says how many records are there in a particular database, they are just referring to, okay, in this particular database, how many rows are there, right? How many fields or attributes are there in a particular database? That just means how many columns are there in my database. Okay. And as you can see, you can store n number of information here. You can store numeric, character, any information that you want. So this is just a simple example. So I have my ID, first name, last name. I have the address, the city in which that particular person stays, and in what state that particular person stays. Okay. So this is just one example of how a database can look like. Okay. Great. So yeah, I think that is the end of what is a database. Do you guys have any doubts or questions related to that? Is everyone clear what a database is? Perfect. Okay. So next thing what I want to tell you guys about is that something called as a RDBMS system. Yes, the recording will be shared. I think you will have to get in touch with the Skillslash team. I'll ask them once. So after like maybe an hour or so, I'll take a quick 5-minute break. In that break, I'll confirm all these doubts. Okay, what is the scene with the recording? Okay. Great. So next thing is going to be a relational database management system. Okay. So whenever we talk about databases, what we think is, so if I go back to my example of insurance, right? Insurance database, this database. So in this database, if you think that all this information can be stored in a single table or a single Excel, then that is not the case. Okay. Because right now we are just dealing with, let's say, only 1,000 customers. Tomorrow, when I am a very mature company and when I'm storing a lot of data, these data sets will be in millions, right? Millions and lakhs of records and columns. Then in that particular case, what I do is I segregate all the information that is, let's say, very relevant to each other in one table and all the information in some other table. So for example, let's say, whenever someone is coming to me for insurance, I will store all the demographic details in one table. Okay, so demographic details are going to be age, gender, location, and things like that, right? So all these attributes or all these columns which help me understand my customer better, right? I will store them in one table. Then, if you think of driving records, number of accidents, number of years driving, right? All these things can be stored in a separate table named as driving history. Then I can have another table of all the information related to the vehicle. So it can have the car manufacturer, car model, car mileage, vehicle identification number, and so on. So basically, instead of storing all the information in one table, I am going to store all this information in multiple tables, right? And the problem occurs when I'm using multiple tables instead of one. You will probably think that, okay, now, right now I was just looking at one Excel sheet. And if I want to just highlight or if I want to retrieve certain information from this Excel sheet, I can simply add a filter and retrieve whatever information that I want, right? But how will this work when I have a distributed database system where all my information or all the data that I'm collecting is not stored in a single table, but is stored in a multiple tables like this. Okay. So this is where RDBMS comes into the picture. Okay. So RDBMS is nothing but a relational database management system. Okay, so this relational database management system is nothing but it helps us join multiple tables together. Okay, it is going to help us establish a link between 2 or 3 tables together. So if I want to pick information, so let's say from this table, I want name and gender, for example, and from another table, I want number of years of driving. So this is just the 3 data points that I'm looking for. But these 3 data points are in multiple different tables. So how do I retrieve them? In order to retrieve them, I will take help of something called as a relational database management system. Okay. So I'll talk about this a little bit in more detail, but right now I am just trying to help you understand at a very high level what RDBMS is. Okay. So there are certain components. When I talk about those components of RDBMS, you will immediately understand what RDBMS is. Okay. Before I continue, let me just quickly have a look at the chat and few questions. We may use MySQL Server or SQL Server for those sessions. You can use either. It doesn't matter. So again, when it comes to SQL, right? SQL is just a syntax and a language. There are multiple tools and GUIs out there which you can use, inside which you can write SQL code. Okay, so it is not necessarily that you just have to use MySQL or Microsoft Server Management System. Multiple things can also be used. Yes, it can also work on Oracle. That is correct. Is there any openings in SQL? I'll talk about this towards the end of the session. Okay, so how SQL is important in the current industry and how you should focus more on SQL. I'll talk about that towards the end of the session. Okay. Great. So one more thing that I want to introduce you guys related to a database is the database schema. Okay, so database schema is nothing but you can consider database schema as the blueprint of your database. Okay, so whenever if you think of your let's say the accommodation that you are staying in, so all the houses, flats, 2 BHK, 3 BHK, whatever it is, every flat has a blueprint, right? This blueprint helps us understand how is the layout of this particular flat. Similarly, when I talk about SQL, SQL also has a certain form of a blueprint which helps us understand our entire database at a glance. Okay. So the technical definition of database schema is that it is a logical definition of the database structure and it defines different objects in my database. Okay, so a database schema is going to help us understand how the tables are interconnected, how are they related to each other, what are the foreign keys and what are the primary keys. I'll talk about primary keys and foreign keys just after this slide. But right now, let's just try and understand what this database schema is. Okay. So for this session, we will be considering this schema that you can see on the screen. So schema is nothing but now if you see in my database, so this database is, we are going to be working on the assumption that let's say all of us are data scientists, right? And we are working for our organization. And the HR manager of our organization wants to understand certain information about all the employees in our organization. Okay, so let's say we are a global multinational conglomerate and we have thousands of lakhs of employees in our system. And the HR is doing some data analysis based on all the employees' data that is present in the organization. Okay, so in order to facilitate something like this, what the HR system or the HR guy is going to rely on, he is going to rely on a database where all the information that is required or relevant is stored. Okay. Now we will understand how is this information stored. This information is stored in different tables. So all the boxes that you can see here, right? All these boxes are nothing but you can assume that they are different tables. When I say tables, it is just a row and column kind of a format. Okay. So table, you can consider table when you start thinking about it, you can consider table as an Excel sheet in your mind right now. Okay. So for example, there is an employees table. What are the different things available in my employees table? I have my employee ID. I have the first name. I have the last name. I have the email address, phone number. What date was that particular employee hired? What is the job ID? How much salary are they getting? Are they getting any commission? Who is their manager ID and what is their department ID, right? So all this information is going to be stored in this employees table. Okay, let me just quickly help you understand this. So I have my SQL workbench open here. So I'll just quickly show you how this table looks like. Okay, so select star from employees. Okay. So I hope you can see my screen. So this is nothing but like this. Okay. So I have my employee ID here. I have my first name, last name, email address, phone number, and so on. So all the information that we were just discussing is available here. Okay. So that is the context. So I have multiple tables like this in my HR database. I have a table for employees. I have a table for jobs. I have a table for job history. In job history, I have again, what is the start date and end date? What is the department ID that they were working for? Then there is a table separate for just the departments. Okay, so department has the department ID. They have the department name, what is the manager ID and what is the location. Okay, so now looking at this image, you should be able to understand my previous point. Okay, previously I said that instead of storing all the information in a single table, if I can store the relevant information in a single table, our entire schema becomes very, very cleaner and it becomes very, very easy to understand. Okay. SQL is a structured query language. MySQL is nothing but a tool that helps you run SQL. Okay. It is just a name of the tool. MySQL Workbench is the tool that I am using to run SQL queries. So this is the MySQL Workbench. Okay. Yeah. So again, coming back to the databases, what I was telling you guys was, so now you can see all the relevant information, all the information that is very, very similar in nature, right? So for example, start date, end date, job ID, and department ID. This is the information that is kind of very, very critical in order to understand what job history a person has, right? For example, street address, postal code, city, province, and country. All these things indicate a location, right? So might as well create a table called as locations, okay? So that is why I am creating multiple different tables to store some information in that table, okay? Now, next question is going to be, I want to retrieve data from this entire database. Okay. So what if I want to select the employee ID? I want to select, so let's say uh, my HR wants to know all those employees who are working in, let's say, one particular city. Okay. Since this data is from the US, let's say the HR wants to understand all the employees who are just working, or he wants to analyze further all the employees who are just working in the city of New York. Okay. So what he wants all, essentially this entire information related to employees and maybe their departments. Okay. He wants all this information, but just for the location of city of New York. Now this city location is not available, or city column or city field or attribute is not available in my employees table, right? So how do we give him that information? What I want now is I want to select all the employees from here. I want to select all the departments from here, but only for the city that has, only for the location where the city is New York, right? So in this particular scenario, in order to retrieve this kind of an information, I will have to rely on three different tables of my schema or of my database. These three tables are going to be my employees table, departments table, locations table, right? So is this clear to everyone that what is the query that we are solving for? The HR wants to know, or he wants to analyze all the employees who are working in the city of New York, right? That is the requirement. So what our job is going to be, we want to retrieve all this information and then give it to the HR, and then they will do the required analysis, right? That is the question that we are dealing with. So in order to retrieve this information, so I'm trying to give you, I can see that few people are mentioning the words as primary key and foreign keys. That is exactly where I'm getting at. So now you can think of SQL like you are trying to interact with the database. Okay, you are using the SQL language to interact with this database. So how are you going to, if you want to frame this query in plain and simple English, how are you going to frame that query? You are going to tell SQL is what you are going to tell SQL. You are going to tell SQL that select all the employees from here, select all the departments from here, but make sure that you do the selection such that the city is always New York. Okay. So you just have to, in plain and simple English, you just have to write down that query. This is the step 1. This is the step 2. And step 3 is going to be city. Okay. So in order to orchestrate this query, in order to retrieve this information, what is important? The one thing that is going to be important is the link between these three tables. Okay. So far we were just talking about these boxes. Now we will start talking about these dotted lines, which are connecting these. Okay, image is not clear, is it? Hold on. Is it better now? I hope it is better now. Yeah. Okay. So far we have been talking about just the employees, the tables, the boxes. Okay. Now what we want is we want to talk about these links. Okay. In order to talk about these links, what these links are essentially going to help us develop a connection between multiple tables. In our current requirement, we want all the information from this table, and the city information from this table. Okay. So now, in order to make these connection with multiple tables, we are going to rely on something called as keys. Okay. So keys are nothing but the links which are going to help us connect the two different tables. Okay. So the image is still the same. We are not going to focus on the image now. We are going to focus on this word called as primary key. Okay. So in order to connect two or more tables together, we are going to rely on two different types of keys. One is a primary key and second is a foreign key. Okay. So first we'll discuss what a primary key is. Okay. So every table in a database will have a primary key. That is the rule of SQL. Okay. Or that is the rule of database. Whenever you are creating a certain database, you will have to create a column which is going to be the primary key. Okay, so primary key is a column in the table. So each and every column, each and every table will have a column which is going to be representing the primary key. Okay, so primary key, what it is going to help us do, it is going to help us identify each and every record uniquely. Okay, so whenever I am talking about, let's say, my SQL data here, right? My data from my employees table. What I want is, in this table, I want to be sure what does one row mean. So this entire one row, what does this one row denote? So now if I look at this table, I can clearly understand that this one row is nothing but the information of one employee. Okay, and this one information is going to be the unique identification number. So this employee ID is going to be the unique identification number. Whenever I say that this data is going to be unique at let's say employee ID, then that is going to be the case that each and every row is going to indicate that it is going to be of one particular employee ID. Okay, essentially what I'm saying, each and every row is a unique employee. That is what I'm trying to convey. Okay, so similarly, all the tables in our database are going to have that unique identifier. So that unique identifier is going to help us understand what is the meaning of one row. Whenever I'm storing data in my table, right? What does one row indicate? Does one row indicate one employee, or is one employee's data split into multiple rows, right? So that is what is going to help us understand. Coming back to our slides, next thing about primary key is that primary key is never going to be duplicated in the same table. Like I was showing you right now, the employees table, employee who has the employee ID as 100, right? That 100 employee ID is always going to denote a one particular employee. Another employee cannot have the same unique identification, right? If it is going to be the case, then we cannot call it as a unique identification. So similarly, the primary key cannot be duplicated. Whenever a primary key is assigned, all the time that one primary key is always going to be denoting one particular employee. Okay, it can repeat in the table, but whenever it repeats, that just means that multiple records or multiple rows still have the same information of the same employee. Okay, that is the intuition behind that. Another rule for primary key is that primary key can never be a null value. Null value is nothing but a missing value or a blank value. You cannot have a blank value in terms of a primary key. You always have to have some sort of a primary key or some sort of a character number mixture together, or either or, and you should have that value present in that primary key. It cannot be null. Okay. And another last rule is going to be, each table is going to have only one single primary key. Okay. So now let's just do a simple exercise. I'll just zoom into this again. So now that you guys know what a primary key is, okay, can you guys tell me what is the primary key in the employees table? So you are looking at the schema here. What is the unique identification thing that is going to help us identify the primary key in the employees table? Employee ID, right? Perfect. So employee ID is the unique identification or the primary key. That is absolutely right. Great job, guys. What other keys or what other columns can I use as a unique identification? So let's say my primary key, for some reason, I want to replace this primary key. What other primary key can I use? What is the other piece of information, or what is the other column that I can also call as a unique identification for a particular customer, particular employee? Okay, department ID and job ID. Do you guys think department ID and job IDs is going to help me uniquely identify a particular employee? Can two employees have the same job ID? Can two employees have the same department ID? Again, listen to the question again. Can two employees have the same job ID? Can two employees have the same department ID? Okay, I can see that some people are saying yes, some people are saying no. The answer is yes. Obviously, one person can have, so job ID is nothing but job ID is going to be something like an IT programmer, right? Or a Java developer. So a Java developer job ID can be assigned to anyone, right? There can be 2 Java developers in my organization. Similarly, for department ID, I can have multiple employees who are having the same department ID. That is going to denote that these set of employees are working for this one particular department. So yes, job ID and department ID we cannot use. What other things? Yes, exactly. Phone numbers and email ID, right? Phone number and email ID are going to be still the case where you can uniquely identify a particular employee. Okay. Right. So why phone number and email ID? Yes, they are going to help us uniquely identify a particular employee, just like the primary key. But what is the thing that is stopping me from doing that? Why can I not use the phone number, or why can I not use the email ID? And why do I need to create another employee ID as a primary key? That is the question now. Why can't I use phone number and email ID? You have pointed out correctly. Yes, email ID and phone number is going to be unique for each and every employee. So why can't I just have that as my primary key? Unique purpose. Yes, they are unique. Yes, null value, right? So in case of email IDs or in case of phone number, chances are that this particular information was not received. Okay. The HR person was for some reason not able to put the phone number into that database, or for some reason they were not able to add the email ID. This particular employee has just joined my organization, right? So their email ID is still not created, but their employee ID is always created, right? So that is the reason why I'm using a separate primary key. Yes, sure, you can use the phone number and email ID as the primary key, but employee ID is a separate primary key that I have created, and it is following the rule that it cannot be null or it cannot be missing. Okay, so now let's just quickly understand what are the primary keys in other tables. So if I have to ask in departments table, what is the primary key there? Can someone tell me? Yes, department ID. Again, manager ID cannot be the primary key there, because one department can have multiple managers, right? So that is the issue there. Okay, so I think now you guys have gotten the clear understanding of what a primary key is. Don't worry, we'll go over a few examples again that will help you understand. But again, if there are any doubts, please let me know. I'll repeat the concept. Okay. So yeah, everything about primary key is clear. I'll just quickly wrap this thing in a high level understanding. Each and every table in our database is going to have a primary key. Primary key is going to help us identify each and every row or each and every record individually, right? Primary key can never be missing. Okay. And each and every table is going to have only one single primary key. Okay. So that is the first key. Now, second key that I was talking about, please guys, remember the backdrop of this conversation is that we are working on the relational database management system. We have just figured out that all our data is spread into multiple tables, and we are planning to get all that data together. Okay. That is the backdrop of the conversation that we are having. Okay. So on top of that, we discussed what a primary key is. And now we are going to discuss what a foreign key is. Okay. So foreign key is the existence of a primary key in some other table. Okay. So for example, if I have to look back here, if you see in this particular departments table, there is a department ID, but department ID is also present in the employees table. Real world example of primary key and foreign key. Real world example, this employee ID is a real world example. All the IDs that you have created are going to be examples of primary keys. There can be other real world examples like Aadhaar card, PAN card, email address, phone number, stuff like that. But again, you cannot treat this as a primary key particularly, because chances are that this information might be missing. Okay, there is nothing against using these different examples as your primary key in your database, but the rule is you cannot have it missing. Okay, so yeah, then coming back to the foreign keys, the first point I mentioned about a foreign key is nothing but existence of a primary key in some other table. So in the departments table, my primary key is my department ID, but my employees table also has the department ID, right? So now this is the thing which is going to help you understand the relational database management system. Okay. Because this key is present in both the tables, what I can tell SQL is join these two tables such that the department ID in this table is equal to the department ID in this table, right? So those two tables can be easily merged, right? So that is what a foreign key is going to help us do. Okay. So again, coming back to the foreign key is an existence of a primary key in some other table. It is used to link two tables together. It can accept null values, right? A foreign key can accept null values, and we can have more than one foreign key in a table. Okay. So again, going back to my schema here, my employees table, the primary key is employee ID, right? Just one primary key. But look at how many foreign keys I have. I have my manager ID, I have my department ID, I have the job ID, which are all primary keys in different tables spread in my database. Okay. So again, one last time, foreign key is nothing but an existence of primary key in a different table. It is used to link two tables together. It can accept null values, and there can be two or more foreign keys in a table. Okay. Yes, foreign keys not exactly exchange values. They are going to help us connect the two tables together. Okay. So exchange is probably not the correct word here. The correct word is going to be the link. Okay. Foreign key is going to help us establish a link between our one table and second table. Okay. So that is the scenario. I'll just explain this one particular example that you are seeing on your screens. Right. So now this is an example that is going to help you understand what a primary key is and a foreign key is. So I have three different tables. I have a table called as an artist. 5 minutes break. We'll take a 5 minutes break at 7. Okay. So probably after 15 minutes, we'll take a 5-minute break. Yeah. So coming back here, I have three different tables in my database. I have my artist table, I have my recordings table, and I have the genre table. Okay. So this is nothing but the artists that are making and creating different forms of music, and they are selling this music, right? That is the idea behind this. So I have my artist, recordings, and genre. So in my artist table, the artist ID is going to be the primary key in my artist table. In my recordings table, the album ID is going to be my primary key, but artist ID and genre ID are still present. Okay. What are the other variables or other fields present in the recordings table? I have my price, I have my album cover, and I have year of release. Okay. So let's say someone wants an information. So we are analyzing this particular database. Okay. We are working for some music label, or our client is a music label, and they want some analysis done on their data set. So what if a request comes up, like for each and every, I want a list of all the artists where the year of release with their year of release. Okay. I want artist ID in one column, artist name in second column, and in third column, I want the year of release. Okay. So in this scenario, what I'm going to do is I'm going to tell SQL that pick artist ID and artist name from this table. Pick year of release from the recordings table, and join these two tables such that the artist ID in this table is equal to the artist ID in the recordings table. Okay. I'll repeat that one more time. When I am writing a SQL query, okay, it is always advisable to write the SQL query in plain and simple English. Okay, guys. Sometimes what is going to happen is there are going to be multiple tables out there, right? Hundreds of tables in the database, and you are trying to retrieve information from multiple tables with multiple conditions, right? So it can become, the SQL query can become quite long and complex in nature. So it is always a good practice to write down in plain and simple English what are the steps that you want to follow. So in this particular step, I'll repeat again what the requirement is. My client has asked for a list of all the artist ID, their name, and all the year of releases for that particular ID. Okay. So for example, if artist ID has released albums in 2010, 11, and 12, then my final table will look like, first column is going to be artist ID, the artist name, which is going to repeat for 3 times, and year of release is going to be 9, 10, and 11. Okay, something like that. So in order to facilitate this, or in order to get this information, what I'm going to tell SQL in plain and simple English, I'll write down my query. I'll write, I want to select the artist ID and artist name from the artist table. Then I want to select year of release from the recordings table. And then I want to join these two pieces of information such that the artist ID in my first table is equal to the artist ID in my second table. Okay, that is how we can link the two tables together. Okay, so similarly, if we go back to our previous example of we were trying to select all the employees with city as this, right? So I'm going to write a query such that select all the information from my employees table, select all the information from my departments table, select the city from my locations table. Okay, and such that the location ID in the locations table is equal to the location ID in the departments table, right? And these two tables I'm going to join such that the the department ID in my employees table is equal to the department ID in my departments table. So in order to join these two tables, I am using department ID. In order to join these two tables, I'm using the location ID, right? So that is how a primary key and a foreign key is going to work. Okay. Is this clear to everyone? The concept of a primary key and a foreign key? Any doubts or any questions here? Do you guys want me to repeat something or give you another example or something? Okay. Any other feedback you have? Do you think I'm going too fast, too slow? Please let me know that also. Okay. Great. One more example. I'll start showing you the example in the MySQL workbench. Okay. The actual data. I'll run few queries and you will get an idea of what is happening there. Okay. Great. Okay. So next thing that I want to highlight one more time is what is the level of the data set. Okay. So one more thing that is not exactly explained out there on most of the education platforms that I have realized is that the level of the data set. Okay. So the level of the data set is nothing but at what level is my data set at. Okay. So in order to help you understand, I will just open one Excel sheet. Okay. So again, same kind of information I have added here. Okay. So now this is my artist ID. My artist ID is going to be A1, A2, A3, A4. The name of the artist, whatever the name is, and let's say the revenue that this particular artist has generated. Okay. So this is my first table. Let me just make this a little bit better. Yeah, this is my first table. And my second table is my recordings table. In this recording table, what I have my album ID. I have the artist ID and I have the price of that particular album. Okay, so this album 1 is going to be costing at 500, for example. Okay, so now here, what we need to understand is what is the level of the data set. So when I say level of the data set, it is nothing but my first table, my artist table is at the level of the artist ID. Okay, so each row is going to be represented by a particular artist. Okay, that particular artist is not going to repeat in my data set again. Okay, but if I go in this particular table, right? So let's say album ID 1. Okay, so album ID 1 has 2 artists associated with it. Artist A1 and artist A2 are both the artists that are associated with album 1. Okay, so let's say they are both male and female singers. A1 is okay, they are not male and female. Let's say there are 2 male people who are singing in this one particular album. Okay, so album 1 has 2 people, A1 and A2, right? And the price for this particular album is going to be, I think this is wrong. This has to be 500. Yeah, correct. Okay, so for album 1, the price is going to be 500. Album 1 is associated with 2 artists, right? So now if I have to ask you what is the level of this data set, okay? So first question was the level of this data set. Level of this data set is simple. This data set is at the level of artist ID. But what is this data set at the level of? Can you tell me? The question is, if I have to ask you what is this table that I have highlighted, the recordings table, right? What is the level of this data set? No, in terms of the, tell me in terms of the column names, okay? You cannot say that the table is unique at recordings level. Anyone? Can you tell me what is the level of this data set? So you cannot have just one album ID, right? So if you say album ID, this data set is at album ID level. My first row has the same album ID as my second row, right? So it is not just album ID. So in this particular scenario, my data set is going to be at the level of album ID and artist ID both. Okay, it is this one pair that is going to be unique. So this is the level of my data set. My data set is at the level of album ID and artist ID. Okay, so say one more example I can give you is, let's say this is customer ID. Let's say this is month, and let's say this is outstanding balance. Okay, so this is from the world of credit risk. Okay, so let's say we are a bank now, and we have customer ID A1, right? Customer ID A1 repeats for, let's say, how many times? This is 8 times. I'll add 4 more times. Right, so this is, let's say, month 1, 2, 3, 4. I'm just creating one more example for you guys. Outstanding balance, let's say 500, 400, 100, 200, and so on. 0, 258, 600, and I'll just copy paste this again. Okay. So now what is happening is, this is my customer ID, right? Let me just make this a little bit better. Yeah. So in this scenario, if I have to ask you from here, my customer A2 is going to start, right? A2, A2, A2 month 1, A2 month 2, A2's outstanding balance in month 1 and month 2, and so on. Okay, A2 is going to go, then A3, A4, A5. All these customers are going to be there in my data set. Okay. So now in this particular scenario, if I have to ask you, what is the level of this data set? Can you guys tell me what is the level of this data set? What is this data unique at? So first we understood on the left-hand side, this particular table is at the unique ID level of artist ID. Okay, so the level of this data set is artist ID, right? Level of this data set is going to be album ID and artist ID both. Okay, both of them together are going to form a pair, which is going to help us understand the level of this data. Whereas in this particular table, what is going to be the let's say unique identification or level? Customer ID and month, right? Absolutely. So this A1, if you see, A1 is going to repeat for multiple rows, right? But this A1 and month 1 is going to be occurring only once. Okay, I cannot have 2 different records of A1 and month 1. Okay, so that is the intuition behind the level of the data set. Okay, so whenever you guys start working with these tables, with these database, you need to understand at what level is this data. Okay, so now if you guys remember that, okay, can you guys tell me what is the primary key in this table that I have selected? What is the primary key? Customer ID, right? Customer ID is my primary key. But previously what I said that customer ID, or sorry, the primary key cannot repeat. Okay, primary key cannot be duplicate. So now if that is the rule, then how do you see multiple primary keys, multiple A1s in the same column, right? The answer is going to be, yes, I can see multiple times the A1 primary key occurring again, but A1 is always referring to one single customer. Okay, A1 is the customer ID, right? A1 is always going to be denoting one single customer, right? Even though this table is not unique at the primary key level, it is still unique at the primary key and the month level. All the rules of my primary key are still holding. My primary key is not duplicate. I am not using the same primary key for 2 or 3 different customers, right? My primary key is still unique. It is still uniquely identifying my customer. It is still not duplicate, and it is not missing, right? So all the rules of my primary key are still going to hold true. Okay, so this is one of the most important things to understand in SQL. Guys, trust me, if you just understand these 2 things, right? What is primary key, what is foreign key, and what is the level of this data set, your job is going to be much, much simpler when you start actually working with the databases. Okay. You can clearly understand that, okay, this particular table, even though the primary key is repeating, it is still unique at customer ID and month level. Okay. So yeah, that is the intuition behind that. So I think primary key is done for now, right? So level of the data set is done. Okay. So a few more things. What does one table contain? How can we uniquely identify each record? Sure, we can use primary key, but right now, just as you saw, instead of using primary key, sometimes you'll have to use a combination of 2 or 3 different variables or 2 or 3 different columns along with the primary key to uniquely identify a record. Okay. So in this particular case, in this Excel sheet, although I have these different records, right? All these records that I have selected are going to denote one single customer. All these records are going to denote another single customer. Okay. So that is the intuition behind that. So, and lastly, at what level is the data stored? So level, again, repeat the level of database. Yeah. So I'll repeat it one more time. Okay. I'll repeat what the level of this database is, and then we'll take a short break. Okay. So the first table is the artist table. In this artist table, the level of this data set is going to be artist ID. Okay. So this is the level of my data set. Right. Similarly, here in this particular table, my level is going to be artist ID and album ID. Okay. And finally, here, the level of the data set is going to be customer ID and month. Okay. So one more time, artist ID is going to help me identify each and every row or each and every record of this table. Artist ID and album ID both together are going to help me identify one single row. And in this particular scenario, customer ID and month are going to help me identify a single row. Okay. So this is the reason why it is important to understand at what level the data set is. Once you understand at what level the data set is, you can easily understand what information is stored in a single row. Okay. Sometimes we'll have to aggregate this information, expand this information, add more information, right? So in order to do that, what are the 3 things we are doing? We are maintaining, managing, and manipulating our databases, right? In order to do any of those 3 things, I need to understand at a very granular level or at a very single row level, what kind of information is stored. Okay. That information you can understand using this level of the data set. Can primary key be considered as the level of data set? Sometimes, yes. So now if you see in this table, primary key is the level of the data set. But in this table, even though the primary key is the album ID, I cannot use just the album ID as my unique identification for the row. Okay. See, foreign key, there is no foreign key in this table, right? In artist ID and recordings table, you can see that in recordings table, artist ID is the foreign key, right? In this particular table, there is no foreign key. But what is the rule? A table must have a primary key, but even if there is no foreign key, we can still store this table in this particular format. Okay, it is not mandatory to have a foreign key. If I don't have a foreign key, probably I won't be able to connect this table with some other table. Okay, but it is not mandatory to have a foreign key. Is that clear? Okay, perfect. Before we took the break, we were discussing the primary keys and foreign keys. Okay, so let's just try to understand few more things that SQL can do. And maybe I'll just also show you the actual MySQL workbench and the SQL schema, HR schema that we were working with. Okay, so yeah, what are the things that SQL can do? So far what we have learned is we have learned that what a database is. After that database, we have learned what a relational database management system is and how two or multiple tables can be linked together. We have also learned what a schema is. Schema is nothing but a blueprint of our database. Okay. So now on the top of all these things, what are the things that SQL can do? Okay, so SQL can do is it can run queries on large database. Okay, right now we are looking at maybe 100 or 200 different rows in our data set, right? But in a real world setting, if you look at all the institutes like banks, insurance agencies, retail, and stuff like that. So in all these scenarios, you will find that there are lakhs and lakhs of records that are stored in a database. Okay, these are the data that you cannot open in an Excel also. Okay, because if you try opening this kind of a data in Excel, it will crash and it will take your computer along with it. Okay, so you need specialized tools like maybe Python or SQL in order to query these large database, right? So SQL first is going to help us run all these queries on databases. It is going to help us retrieve the information. What it can also do is it can insert an information, it can update certain information, and it can delete a certain set of information from a table. Okay, so apart from retrieving, it can also insert, update, and delete a particular information or value in a particular database. It can also be used to create a new database from scratch. Okay, what we can do is we can define our tables. These are my 5 tables. Each table is going to have these many set of variables. These are my primary keys. These are my foreign keys and stuff like that. All those definitions you can write in SQL also. Okay. But most importantly, as running queries on multiple databases and retrieving relevant information is the most important thing that SQL can do. Okay, so having said that, let's just quickly understand SQL. Okay, so introduction to my SQL workbench. This is nothing but the tool that I am using, right? So it looks something like this. So you will probably, whenever you try running SQL queries, this is just one of the tools that you can use. Multiple tools will be out there. The format will be the same. The best part is that the SQL syntax, the text that we will be writing, right? This text is always going to stay the same. Okay. So no matter which tool you are using, the SQL syntax or SQL language is always going to stay the same. So this is where I write my queries, or this is where I write my codes. So for example, these are the multiple queries that I have written. So you can write something like this, right? This is where I can write the queries. Once I run this query, once I execute this query, so I can see all the information or all the output here. Okay, if there is some error, so for example, let's say I remove this S and try running this query, right? It is going to throw me an error here. Okay, so all the errors and issues and bugs, you can start seeing them here. Okay, so that is one thing. Next thing is going to be on the left hand side, you will start getting access to all your database. Okay, so I'm not sure if I'll be able to zoom this. Can you guys see this? Probably I can do something like this. I can take a screenshot of this and try to zoom that. Where did my screenshot go? Just give me one moment. Apparently that screenshot is not available. Okay, anyways, I think you guys can see this. This is nothing but this is where my database access is. Okay, I can access all my database from this particular panel. Just a moment. Yeah. So the schema that we were looking at, right? I was the one who was taking the screenshot. I wanted to zoom on this particular area. That's why I was taking the screenshot. So yeah, on the left hand side, I have my entire database or my schema. In this HR schema, you can see that there is a table, there is a drop down called as tables. In this table, I have all my tables. Okay, previously we were looking at our HR schema. Where did it go? Yeah, this one, right? This. So employees table, job history table, jobs table, departments table, right? All these different tables you can find here. Okay, so I have my countries. In the countries, I have columns like country ID, country name, region name, right? Similarly, I have my departments table, employees table, jobs, locations, persons, regions, and whatnot, right? So these are the tables that I can see from here, right? This is the overall explanation for what my SQL workbench can do. Okay, so let's go back to here. Okay, so we did the introduction to MySQL. We know how our data can be stored, right? How we can access the data. And now what we can do is I'll run few examples of the queries that SQL can handle. Okay, so like any other computer language, right? Python, Java, C, whatever it is, right? All these languages have certain inherent inbuilt functions in them, right? Similarly, SQL also has certain functions inbuilt. Okay, so one of the functions, basic functions in SQL is going to be the select statement. So this select statement is going to help us select a particular set of information from a particular set of tables. So what we can do is we can write this query, select this particular column name from a table name, and we can print that particular output in our table. Okay, so I'll just do that. Okay, so I know that employee ID is available. So I'm just writing select employee ID from my employees table. Okay, pretty straightforward structured query language. Okay, I'm going to write my select statement first. I'm going to write which variable I want to select or which column I want to select. And then from which table do I want to select that particular information, right? So I'll just select this. And once I run this, you can see that I can get just that one particular column as my output. Okay, so this is the employee ID that I just requested. Okay, so similarly, extension of this particular SQL statement is if I want to select multiple columns, I can just write them like this. So column 1 separated by a comma, column 2, column 3, and so on. Again, at the end, I am just going to write the from statement. Okay, so essentially, if you look at it from a plain, simple English standpoint, right, what we are telling SQL, we are telling SQL select these columns from which table? From this table, right? This is the information that I'm telling SQL. So apart from employee ID, let's try to select first name. Let's select last name. I think that should be enough, right? So multiple columns, I can also select email ID. How is the email ID stored? Sometimes I also forget how it is stored. Okay, it is just email, not email ID. Right, so this is how you can use this pane. Okay, so I wanted to select email, but I don't know what is the how email is written, whether it is email ID or email underscore ID. I have no idea. So I can just look at this drop down menu and see that, okay, it is email. I can write that. And once I run this query, I can have my employee ID, first name, last name, and email. Okay. Can you please tell that SQL, MySQL, PGSQL are same and are different types? See, SQL is the structured query language that we are trying to get introduced to. Okay, all this MySQL and all the other tools are different tools in which you can execute the structured query language. Structured query language is the code that I am writing right now. This format, this syntax that I am writing right now is the structured query language. Okay, you can use this structured query language, this syntax in multiple different tools. MySQL is a tool in which I am executing this query. Okay, so that is the difference between what is SQL and what is MySQL. Is that clear to everyone? Okay. Yeah, so I can select multiple columns. And lastly, if I want to select the entire information, I want to display all the columns instead of writing the names one after another. What I can do is I can just write select star. Okay, when I write select star, what it is going to do is it is going to select all the attributes or characteristics from that particular table, and it is going to display in this format. Okay, so that is how the select statement can be used. Okay, I just repeat it one more time. Select statement is going to help us retrieve information from a database table. Okay, what we are going to tell SQL is we are going to tell SQL that select these many columns, single column or multiple columns, from what table? From this table. Okay, if you want to select multiple columns, you can just write them as comma separated names. If you want to select all the columns, you can just write select star from that particular table name, right? And all the output will be given to you. Okay, any doubts in the select statement? Clear? Okay, perfect. Great. So let's move on. Next is going to be the data types. Okay, so this is slightly important here. So now that you guys are trying to get into the world of data science, this is more or less going to stay same, no matter if you're learning SQL or if you're learning Python or you're going to learn R. Okay, so all these things, wherever the data is stored, the data is going to be stored in certain format or certain data type. right? So similarly, in SQL, there are three main data types that we are going to deal with. There are other data types like Boolean and all, but initially, for the sake of understanding, let's just look at three different data types. First data type is going to be a normal number where you can have a integer or a floating point. Next is going to be something called as varchar, which is going to help you store characters. Okay, you can store strings, letters, different strings, spaces in between the strings and stuff like that. Essentially, everything is going to be treated as a string. You cannot add one string to another string, but you can add one number to another number, right? So that is why it is important to understand what is the different type of data types available in SQL. Okay, so first is going to be numbers. Second is going to be the character variables. And third is going to be something called as a date variable. Okay, so in most of these languages, Python, SQL, R, what we can do is we can define that one particular column is going to be of date type variable. Okay, once we define it as a date type variable, what we can do is we can start doing mathematical operations on it. If I don't store this particular string as a date type variable, what SQL is going to see is SQL is going to see this as 02/13/2011, right? This entire thing is going to be considered as a string. And now what if I want to do calculations like difference, all the employees who were hired after a particular date, right? If I want to do that, what am I going to do? I'm just going to say that tell SQL that, okay, select all the employees where the date is greater than a particular date, right? If I want to do that particular operation, I need my date variable to be in that format. Okay, it cannot be in the format of a string. Okay, so that's why it is important to have that particular variable stored as a date type variable. Okay, so right now we'll just look at these three different data types, right? First is going to be numbers, second is going to be characters, and finally we have a date variable. Okay. Another important thing to remember here is each and every column in our table is going to have one single data type. Okay, it is not going to be the case that my first column is going to store in few rows, it is going to store numbers, and in few rows, it is going to store strings or characters, right? That is not going to be the case. That is not allowed in SQL. In SQL, what is going to happen is each and every column or each and every attribute is going to have a single data type, right? If I want multiple data types, I'll have to create different columns, but each and every column, that all the rows in that particular column are going to retain the same data type. Okay, that is the important thing to remember here. Okay, any doubts related to what are the different data types in SQL? You guys want me to repeat anything? Okay, cool. Perfect. So we saw the first function called as the select statement in SQL, right? Now let's look at another function called as distinct. Okay, so distinct function is going to help us understand or eliminate all the duplicate records from our table. Okay, and again, one more thing to remember now is the name of SQL. Full form of SQL is structured query language. Okay, there is certain set of rules that we have to follow to write this code. Okay, so all our functions, right, select function, distinct function, and all the other functions that we will get introduced later, right, all the functions have to be written in a particular order. So in this particular scenario, the distinct function or the distinct statement is always going to come after the select statement. Okay, and before the column name, right? So always this is going to be the case. Example is going to be, so let's say, what example can I give you? Okay, is this screen visible to everyone? Can you guys see the department ID here? I'm not sure how I can zoom this, right? There is a department ID here, this particular column I'm referring, right? So if I see employee 100 and let's say these three employees are from department 90, then if I see these whatever 4 or 5 employees are from department number 60, right? Now what I want to do is I want to understand how many departments, unique departments are there in my data set. Okay, so what I can do is I can write underscore ID, right? If I run this query, what it is going to show me, it is going to show me this entire list, right? But I don't want to keep scrolling through this entire list, right? I want SQL to remove all the duplicates from here and just show me all the relevant distinct IDs. So that is where the distinct command comes into the picture. Okay, so I'm just going to write select. What do I want to select? I want to select distinct department IDs. I just don't want to select department IDs, but distinct department IDs, right? You can see how it is very, very similar to SQL. Very, very similar to plain and simple English language, right? So that's why I was stressing on the point that whenever you are trying to write a query, first try to write that query down in plain and simple English and then start coding. Okay, then it will be easier for you to understand. So yeah, as you can see, once I run this query, all the distinct department IDs are now visible here. Okay, instead of going through that entire column and finding out which employee ID, how many times it is occurring and what are the distinct IDs, right? Instead of making note of that, SQL is pretty intelligent to handle this kind of a stuff. So I just use the distinct command here. Okay. Any doubts here with how I can use the distinct command or what is the distinct command? Okay, perfect. Yes, unique will also work, but distinct is one of the things that is most commonly used. Can I repeat? Yes, I can repeat. So the thing was, let's say the HR person who has joined our organization, right? The HR person wants to know how many distinct departments are there in my entire organization, right? So initially what I did was I just did this. This is my entire data set, right? I have employee ID, first name, last name, and so on. So I have this department ID column here. So the HR wants to understand how many unique departments or how many distinct departments are there in the organization. So in order to give this information to the HR, what I can do is, one of the things is underscore ID. I can write department underscore ID. I can run this query. I get all the values here. Okay. Once I get all the values here, instead of having all these values, I can see that, okay, 10 is one of the ID, 20 is one of the ID, 30 is ID, 40, 50. I can make a note of all these things, or instead of that, I can use the distinct command. Okay. Once I use the distinct command and run this, I will just get the distinct IDs here. Okay. Is that clear? Great. So, what does the star do? Star is going to help us when I write select star. It is going to select all the columns from this employees table and display it. Okay, that is why select star. Instead of selecting star, I can write employee underscore ID. I can write first name and so on, and I can display this. But what if I want to display all the columns? Then instead of writing all the names of the columns one after another, instead of doing that, I can just write select star here. And once I do that, I'll get my entire table displayed here. Okay, great. So, yeah. Next thing is going to be the comparison operators. Okay. I'm not sure how much of a coding background you guys have, but comparison operators are going to be used just like we use them in mathematics. They are going to be used in the world of SQL, Python are also. Okay. But there is just certain way of writing these comparison operators. So for example, what if I want to select all those employees where the salary is greater than a particular number, right? In that particular scenario, what I have to tell SQL, select employees, right? So, okay, select first name, last name, employee ID from the employees table where the salary is greater than, let's say, 5,000, right? So this is where the comparison operators are going to come into the picture. So I can have greater than, less than, greater than or equal to, less than or equal to, not equal to. If I want to write not equal to, this is how I can write not equal to. So this is one way of writing not equal to. This is another way of writing not equal to. Okay. So for example, if I want to select all the employees who are not from the city of New York, right? So I can just tell SQL, okay, select all the employees where the city is not equal to a particular name, right? I can write a text there also. Okay, so this is where the comparison operators are used. Okay, so firstly, these are the comparison operators. How they are used is they are used to compare objects. The comparison can be based on a numeric condition or a character condition. Okay, salary greater than 5,000, name equals to John, right? City equals to New York, right? So I'm using both numeric and character values in order to use these comparison operators and try to make some filters from my data set. Okay. Then what else? Yeah, one more thing to highlight here is whenever we are going to write, let's say, I'm just going forward and helping you guys understand one thing. First name. Okay, so let's say first name is Steven, right? So I want this Steven here. First name equals Steven. I cannot write it this way. Whenever I'm writing a string, right, I just have to mention the string in a quote. Okay. So that is one important thing to remember. Whenever we are using comparison operators, right? Whenever we use comparison operators and whenever we want to make a filter based on the, let's say, character value, then that character value has to be given in quotes. Okay. Instead, if I'm doing salary, let's say greater than 5,000, then I don't need to put 5,000 into quotes. Okay, that is the only difference. Whenever I'm using comparison operators, if I'm using the comparison operator to do to use it with a number, I don't need to mention that number in quotes. Whereas if I'm doing it with character, I have to mention it with quotes. Okay. Yes, we can also go with double quotes or single quotes. That is true, but just be slightly cautious here. Sometimes double quotes work, sometimes single quotes work. Okay, so I'll just check if it works in this particular case. So no, it doesn't work here. Okay, so my SQL workbench, let's say because of the version that I'm running, or maybe it's not updated, it is not letting me use double quotes. Okay, but double quotes is not wrong. Okay, there are certain other tools in which double quotes can also work. Okay, in this particular version of MySQL that I'm using, it is mandatory to use single quotes, right? Why is it not? Okay, I'm using salary. That's why. Did you guys realize the mistake that I was doing? Instead of saying first name is equal to Steven, I was saying salary is equal to Steven, and SQL is getting all confused. Okay, sorry for that. So yeah, now when I have written Steven, there are two Stevens in my data set, so both are returned here, right? Okay. So next is the where clause, which I was going to explain anyways. Yes, I will show the comparison operator again. Okay, so comparison operator. Before that, let me just quickly explain another function which I was just using. It is called as the where clause. Okay, so where clause is going to be used in SQL when I want to do some sort of a filter. Okay, if I want to filter out all my records where salary is greater than, let's say, 5,000 or something, or if name is equal to Steven or something like that, whenever I want to make that kind of a filter, I'm going to use the where clause. Okay, example is going to be this. So I'm demonstrating both the cases here. I'm demonstrating how to use the where clause, and I'm also demonstrating how to use the comparison operator. Okay, so what I'm doing now is I'm selecting employees where the first name is Steven. Okay, so in order to do that, I have written first name is equal to Steven. So here what I can do is I want all the employees where first name is not equal to Steven. So instead of putting equal to, I just put exclamation and equal to. And when I run this, I get all the names. And yeah, it is very difficult to tell you, but there is no Steven in this particular data. Okay, so this is one way of using comparison operator for text. Next is going to be salary. Let's say salary is greater than 10,000, right? So again, I am selecting all the records from my data set. From which table? From the employees table. What is the condition? Where salary is greater than 10,000, right? Once I run this, these are all the employees whose salary, if you see, is now greater than 10,000. Okay, so greater than, if you see, is there anyone who is exactly 10,000? I don't think so. If I write greater than or equal to, probably I will get all the records when salary is greater than or equal to 10,000. Yeah, now I am seeing few records where salary is greater than 10,000. Previously, if I didn't write equal to, it was just showing all the records above 10,000. But if I mention greater than or equal to, it is also showing me records where salary is equal to 10,000 also. Okay, similarly, I can do greater than, or maybe I can do less than. Instead of, let's say, 10,000, let's put 2,000. And if I run this, There are no records. There is no one who is less than 2000. Are there any people who are less than 5000? Yes, there are multiple people here, right? So this is the way in which we can use the comparison operator and the where clause. Okay. Is this clear to everyone? Any doubts or any questions here on what is a where clause? What are the comparison operators and stuff like that? Perfect. Okay. Great. So let's go back to our slides. We were looking at the where clause. Okay, so I think we'll skip the tasks for now. We'll look at another function. Okay, so this function is going to be order by. Okay, right now, if you see, all our results are not exactly ordered by. Okay, so 4,800 is first, then next is 3,000. After that is 2,900. Right. If I want to order these, right, from let's say ascending or descending order, right, I can use the order by command here. Okay, so I can do order by on both the things. Okay, I can do order by on numeric variables as well as character variables. If I do it using character variables, the order will be alphabetical in nature. Okay, all the output or all the records in my final output will be ordered by either based on the alphabetical order or based on the numeric order that I have specified here. Okay, I can specify. So again, same kind of a thing, same kind of a notion. I am writing my select statement first. Select which column do I want, from which table do I want that particular column, and final output. Once I get that output, how do I want that order? How do I want that output to be ordered by? Okay. If I want to use the where clause, the where clause is going to come first. Once the where clause is written, then I'm going to write order by a particular column name. Okay. And in the bracket, I can mention whether I want it ascending or descending. Okay. So let's say what I can do here is order by salary, right? If I just write this and execute this, you will see that my salary is now ordered in a ascending manner. If I don't mention here, right, order by salary, I haven't mentioned ascending or descending, right? If I don't mention ascending or descending, it is by default going to be using the ascending order. Okay, so I can use order by salary, and if I want to show it in a descending order, I can write DSC. Probably the syntax is messed up here. Yeah, bracket is not required. So if I do it descending, my entire output is now ordered by in a descending fashion. Okay. I can also do order by, instead of salary, I can write order by, let's say, first name. Underscore name. We'll remove descending for now. So notice that my condition for where clause is still there. Okay, my output is going to contain all those customers who have all those employees whose salary is less than 5,000. Okay, now when I execute this, this syntax error. Yeah, you will see all my data set is ordered in an alphabetical order. A comes first, then B, C, D, right? So my entire data is now ordered. Last is going to be W. Okay, I can again write descending here. So W will come first, right? Winston has come first and A will come at the last. Okay. Okay. Any doubts regarding the order by command? Is everyone understanding how we are using order by? Okay, let me just go over the doubts. Where do we use group by? Yeah, group by again, good question. We are not covering the group by statement today in our today's session, but I'll just give you a quick understanding of how we are using the group by statement. Okay. Let's say, okay. So slightly complex in nature, so don't go too much into the query. So what I'm going to do is, so what I want is, I have my department ID, right? So I have my department ID. For each department ID, I want to understand how many customers, how many employees are there in each and every department. Okay. So if you see department 50 is here, then again, there is 50 here. if I scroll down, there are multiple departments here, right? So what I want is, I want to understand for each and every department, how many employees are associated with that department. If I want to do this, then what I need the group by statement in this particular scenario. So what I'm going to do is, I'm going to select department underscore ID, right? Is that the correct spelling? Department ID. And then I'm going to write count of employee underscore ID. And I'm going to select this from employees table, and I'm going to do a group by on department underscore ID. Okay. So once I do this, what happened here? Unknown employee underscore EMPL syntax error. Yeah. So this is my final output. Okay. So now this is how the group by statement can be used. Okay. So what I have as an output is, I have all the departments, and in this department, what SQL has given me is how many employees are associated with each and every department. Okay. So this is how the group by statement can be used. So you can create a group of any particular variable in your data set, and using that group, you can start selecting other things. Okay. So now that we are here, I can also show you. So for example, I want this. So first variable is going to be count of employee IDs. What I also want is, I want to understand for each and every department, what is the maximum and minimum salary. So what I can do is, I can select max salary, right? I can write that here. I can write minimum of salary, and then run this. Okay. So now what SQL has done is, for each and every department, it has given me what is the count of employees. For, let's say, department 10, the maximum salary is 4,400 and minimum salary is also the same. So that is because there is just one employee here. If we see this particular department 30, which has 6 employees, then you can see that the maximum salary is 11,000, whereas the minimum salary is 2,500. Okay, so this is how group by statement can be used. Okay, what is the difference between group by and having clause? Again, a great question. But I think you will probably have to join the sessions for that. We won't be covering that one particular thing today. Okay, that's an interesting question. Why count? Because I want the count of employee IDs here. That is why I'm using the count. Okay, perfect. So yeah, next is logical operators. I think we'll skip this. Okay, let's not skip this for now. Okay, logical operators. Again, logical operators are going to be used in case of the where clause. Okay, so what if right now, let's say if I remove all this and I go back to my where condition, yes, okay, I'll remove this thing. So now I have this one condition, okay, where clause, where salary is less than equal to 5,000. But what if I have multiple conditions? I also want to select employees where department ID is, let's say, equal to 30 or department ID is equal to 100, right? Or I want to have the output such that select all the records where either the salary is greater than 5,000 or the department ID is 30, right? So if I want to write multiple conditions, that is where this logical operators are going to come into the picture. Okay. And again, if you guys have certain background of mathematics or maybe engineering, you will probably realize, or you probably must have gone through these concepts already. Okay. So if this is nothing but a table which helps us understand if we write multiple conditions and if we use either the AND logical operator or the OR logical operator, how will the results be? Okay. So for example, if I'm using the AND logical operator, let's say my where clause is going to be one condition and second condition. So it is going to give me all the records where both these conditions are true. Okay. So that is where the AND clause is going to be used. If I use the OR clause, it is going to give me records where either of the conditions are true. Okay. So for example, and department, I think we'll have to write department ID is equal to 30. Yeah, it works. Okay. So all the people whose salary is less than 5,000 and the department ID is 30. Okay. Since I'm using the and condition, what SQL is doing is it is returning me all the records where both these conditions are true. Okay. If I write instead of and, if I write or, it is going to give me an output where either of these conditions are true. Okay. So when I run this, I have so many records now. So now in all these records, if you see, either of the conditions are true. So in this particular scenario, the salary is less than 5,000, but the department ID is 60. I'm still getting that as an output. Why? Because I'm using the or operator or logical operator here. Okay. And yeah, that is how you can use it. If you are using it in a where clause, you can write this column name from what table you want to select, and then the where condition. You can have where condition 1 and condition 2 and condition 3, multiple conditions you can have, doesn't matter. Okay. As long as you are clear of how you are using the and or operator, right? The syntax is going to stay the same. Okay. So this is the syntax for the and operator, and this is the syntax for the or operator. Okay. Next is going to be one more operator, which is called as the not operator. Okay. So not operator is basically not condition. Okay. So where not condition. So if I'm writing where salary is this, and instead of writing this, where salary not, if I write this, it is going to show me all the records of the inverted condition. So it is basically going to show me records of all the employees where salary is not less than equal to 5,000. Okay. So essentially all the people where salary is greater than equal to 5,000. That is what it is going to show me as an output. Okay. So that is the not operator. And yeah, let's go over this one last logical operator, which is called as the in operator. Okay. Now, what is going to happen is, let's say, let me remove this. Okay. Where department ID is equal to 30. Now, let's say, first I'll just select and run this. Okay. So this is my entire table. Okay. I just selected this particular syntax and I executed the query. If I do that, it executes only the selected portion of my code. Okay. It hasn't run this particular part of the code. Okay. So now here, what I want is, I want to select all the employees from multiple departments. Okay. So what I'm going to do is I'm going to select this. I'm going to write and here I'm going to write department ID is equal to, let's say, 60. Then I'm going to write and department ID is equal to 100 and so on. And one more and, let's say. Sorry, I clicked on something else. What happened? Yeah. And department ID, let's say 50. Okay. This is the query that I want to execute. If I execute this query, it is not going to give me an output. Why? So I make any error. Okay, let's just try it with two conditions. I'm making some mistake. Just hold on. Let me debug this. Okay, this works. Oh yeah, I'll have to put or. That is correct. Thank you so much. I'll have to put. It cannot be from both the departments, right? Yeah, what a blunder. Yeah, this. Instead of and, I'm going to write or. And yeah, once I run this, I'm going to get the output, right? So now the challenge here is I don't want to write all these statements one after another, right? I don't want to keep mentioning department ID is equal to 30 or department ID is equal to 60, department ID is equal to 100, right? So the intelligent way of doing this is to use the in operator. Okay. So what I'm going to do is the in operator picks a range of multiple options from the same column and allows you to specify multiple values in the where clause, okay, or the or clause. So it is up to us. So instead of using just the where clause, so I'm going to write where a particular column in, and I'm going to mention all the conditions there. Okay. So how it works in SQL is instead of doing it this way, let me just copy paste this query here. Okay. So instead of doing it this way, what I'm going to do is I'm going to use the in operator. So department ID in, and then I'm going to write 30, 60, 100, and 50. That's it, right? Once I do this, I get the same output as I was getting before. But now, if you look at my query is much cleaner and easy to understand. I don't have to maintain multiple lines of code, multiple complex lines of codes and stuff like that. Okay. Is this clear to everyone how I'm using the in operator? Any doubts or any questions here? Okay, perfect. Okay, I think we have time for one more function. Let's just try to go over that. Okay, between, just give me one moment. Next logical operator that we were checking for is we are going to check between and operator. Okay, so between one condition and another condition. So let's say I want to select salary between 2000 and salary between 5000, right? So instead of writing two where conditions where salary is greater than 2000 and salary is less than 5000, instead of doing that, I can simply write between command. Okay, so syntactically it is going to look something like this, where salary between 2000 and 5000. This is my condition. If I execute this, I'm going to get salary between 2000 and 5000. The other way of doing the same thing is going to be, I can write something like this: select employees where salary is greater than or equal to 2000 and salary less than equal to 5000. Okay, so instead of writing this, I have just written the same query using a different function called as the between function. Okay, any doubts here? Is everyone clear with the between function? Okay, great. Okay, one last logical operator we can do is we can implement something called as the like operator. Okay, so now let's say just one last function, and then we can open up it for some question and answer. So select star from employees, right? In this table, this is my table. In this table, what I want is I want to select all the employees whose first name starts with the letter S, right? Right now, what I can do is I can write where where first name is equal to a particular name. But what if I want to select all those employees where the first name starts with the letter S, right? So in that case, what I'm going to do is I'm just going to select star from employees. I'm just going to give it a proper indentation. I'm going to use the like command. Okay. So in this case, from employees where first name like, and the way to write this is going to be I have to write it with the percentage sign. Okay, so again I will be using quotes a and percentage sign. Okay, sorry, the other way around. Okay, so essentially what it does is, what it's telling SQL is select all the first names where sorry, not a, let's do it with S. Okay, so select all those employees where the first name starts with S. So if I run this, slight hiccup. If I mention S after the percentage sign, it gives me all the first names that are ending with the letter S. If I want it at the start, I just have to bring it at the start of the percentage sign, execute the same query, and now it is going to give me all the employees who are starting with the letter S, whose first name starts with the letter S. Okay. So yeah, I think that's it. That's it for today. Few things I want to highlight one more time. So we learned the where clause. We learned how to use the like function, right? We also learned how to use the comparison operators, right? We know how to select multiple columns from our tables and stuff like that, right? So a few basic things that we needed to understand about SQL, right? Apart from that, trust me, there are only maybe like 10, 12 different SQL functions that you need to really remember, right? If you can just master these 10, 12 SQL functions, right? These are the 10, 12 functions that are most commonly used in the industry. So if you can get a clear understanding of how these different functions work, you should be getting very, very good at using SQL in a workplace setting. Okay. So that is one small tip I want to leave you guys with. No, this is not a session which is going to go for a while. It is not a multiple day session. Today was just a webinar to give you an introduction to SQL. If you guys want to learn more about SQL, if you want to understand the different functions and what are the other things that we can do with SQL, you can join the course at Skillslash Academy, right? So this was just an introductory session for that. Later on, Skillslash, if you go on their website, you will be able to understand what are the different courses that Skillslash provides. So I have been teaching with Skillslash for almost a year and a half now. I teach SQL, Python, computer vision, natural language processing, and topics like that. Machine learning deployment is also one of them. So yeah, I'm the instructor at Skillslash. Apart from SQL, I can teach all those things also. Okay. Okay. So now I think we have like 4 minutes. If you have any questions related to SQL, I can take those questions now. Is joins important for industries? Yes, joins is very, very important for industries. Because as I said, in SQL, all your information is going to be spread across multiple tables. Okay, it is not going to be the case that a single table is going to have all the information that you need, right? That is not going to be the case. So in order to retrieve information from multiple tables, you will have to use joins. So multiple tables will have to be joined together and information should be retrieved from that. Okay, what other questions? How to apply for certificate? I think the Skillslash team, you can reach out to them. They will get in touch with you. You'll have to, I think in the middle of the session, you guys were told that you'll have to sign up for an assignment, right? So once you complete that assignment, you will be getting your certificates. So assignments will be based on the today's session that we had, right? What about jobs on database? Why don't you provide workshop certificate? We will provide workshop certificate, but for that you will have to solve that assignment. Which app is good for doing code in SQL? Again, not exactly important. Doesn't matter what app you are using. The syntax and the queries that you will be writing are going to be exactly the same. Okay. It is not going to be that if you use some other function or other tool, you are going to be writing a different code, right? That is not going to be the case. So SQL, the structured query language is going to stay the same no matter which tool you are using. Okay. Okay. Which topics are important to be placed in the company? Tell one by one. Okay. So I won't cover all the topics, but I will tell you this thing that if you are freshers in the field of data science, SQL is definitely one of the most important skills that you need to pick up, right? Most of the industries where databases exist, they are using SQL extensively. Even today, a lot of companies rely on SQL for creating different dashboards, for structuring or retrieving information from different tables and stuff like that. So yes, SQL is going to be definitely one of the very, very important skills that you need to pick up. And as I said, it is not at all complex. Probably today's session must have given an understanding of how simple it is to learn SQL, right? There are, as I said before, 10 to 12 functions which are most commonly used everywhere, right? So if you just understand these 10, 12 functions, you will be able to get a good enough job where SQL is used. And trust me, SQL is most widely used tool in the domain of data science. Okay, so multiple jobs are available out there, especially for freshers who are just starting out in the field of data science. Okay. Jobs opportunities in SQL I've already covered. Business analyst or data analyst, best role is in the best in future. Again, two different roles. Business analyst is a term which is pretty vaguely used in the industry right now. Sometimes business analysts are the people who are going to be the link between technical and non-technical people. That's how I know business analyst. But sometimes people with the role of business analyst will also do some data science related task. So again, essentially it is up to you. Whenever you look at a job description, just try and understand whether you will be dealing with a certain amount of data or not. If you will be working hands-on on a particular data set, then probably the data analyst role is best suitable. But again, these two terms are used very loosely, right? Sometimes business analyst roles will also be meaning that you will have to use SQL. So just be careful with that. Look at the job description, and from that job description, try and understand what the exact role is. Can you please send the assignment link? Assignment link will be available on the YouTube, and I think the Skillslash team will help you get the assignment link. Let me just see if the Skillslash team is here. They are not here. Okay. Any other questions? Which are the topics that are important? SQL, if you ask me SQL, all the topics in SQL are pretty important. Again, 10, 12 different functions that you need to master. Employees table you will get if you join the sessions. We will provide all the code to create this table or deploy this table in your particular local environment. Suggest any certification for SQL. Skillslash is going to be one of the places where you can get certification. How much SQL is needed for ETL testing? ETL testing is slightly a role which comes under the domain of data engineering. So these guys are the people who are actually designing and developing the databases. Okay, so there is a difference between a person who is retrieving information from a database and the person who is actually creating a database, right? So all the people who are creating this database, right, will be using ETL. And yes, when you use ETL, sometimes SQL is used in ETL for testing purposes. So not extensively, but yeah, it is used while working with ETL testing. Okay. Thank you. Thank you for your time. Yes, most welcome. Thank you guys for joining the session. Yeah, I think that's it. The links and everything will be shared to you. I think you must have registered with your email ID, right? You will probably get all the links for your assignments and YouTube videos there. Or this recorded video will also be present on YouTube. If you want, you can check it out there later. And if there are no further doubts and questions, we can conclude for the day. I hope you guys join Skillslash and I get to teach you guys again. Thank you so much for joining the session. I hope you understood some basics of SQL and found it slightly valuable. Yes. Thank you. Thank you, everyone. Thank you for joining. Hope to see you in the Skillslash batch. Okay, great. Thank you. Thank you. Have a great weekend. Bye.